And we also learned last time we met balanced versus unbalanced forces. We know that a balanced force is going to have the same magnitude in opposite directions, and it does not affect the acceleration of an object. However, unbalanced forces, you have one or more unequal forces, and this will cause the object to accelerate. We also know that a force has both magnitude and direction. It's a vector quantity. You also know how to calculate the net force. You know that if they're going in the same direction, you're going to add them. And if we're going in opposite directions, you're going to subtract them. Okay? Questions for me? All right. So now I am going to do a demonstration. This will be interesting to see if I can do this. And, oh yes, perfect. Let me pin this person here. Beautiful. And they can pin or spotlight. And would that be better? Beautiful. Okay. So on your formative, now that I know how to do that, let me go back here. Okay. So on your formative now, we're going to scroll down to number 3. There's going to be 2 demos. We have demo 1 here, where I'm going to show you a film canister and a car striking a barrier. So let's focus on numbers 3, 4, and 5. Again, I'm going to stop sharing, and hopefully I can get it to just focus on me. Okay. All right, here we go. I need to mute. Yes, let's try that. All right. So can you see me now over here? All right. Pin this video. So find me over here and pin me. I'm waving at you. Don't pin the classroom. If you want, I can turn off that video so it's more obvious. Okay? All right. Let me put the chat up here so I can see you and participants. All right, so number 3. We have a barrier. Let me actually lower this down so you can see the table. And please, in the chat room, in the chat box, tell me if you need me to move things or talk louder, etc. Okay? So I have this block, and this block is going to be our barrier. It's the same block I used for the Newton scale. Okay? I have a car. I have 2 wooden cars actually, but our first demo, part A, is with this wooden car, and we have the film canister. Inside the film canister, just to give it more mass, we've added a couple bolts in here, so it has more weight to it here, okay? So for number 3, you're going to draw this scenario, okay? I'm going to go ahead and apply a force to the car and allow it to crash into the barrier, okay? So, ready? I'll do it a few times for you. Why can't I see that chat? Okay, here we go. Okay, I'll do it again. Do you need me to scoot over here? Is that better? I'm going to hold this one down because I don't want it to go flying. Okay. Yes or no? Can you see this? I see a thumbs up. Click yes or no on the participants. Again, you should pin this video of me. Good. Okay, let's do it one more time. Beautiful. Okay. All right. Go ahead now on number 3. You're going to draw this diagram in the chat box. Do you think when I draw a diagram, you should draw Miss King? No. Okay, good. Do you think we should include the boards in the back? And I have a couple, like I have this cup here. Is this going to be important? No. Okay. In the chat box, write one of the major components in this system in the chat box. Good. I heard somebody wrote the car. Good. The barrier. Let's see anybody else. There's one more thing we need to include in this demonstration. Make sure you include the film canister. So you should have 3 major things in here, okay? We have the barrier, the canister, good, and the car. So go ahead, I'm gonna turn off, I'm gonna reshare, that's what I'm gonna do, okay?
Miss King, you're muted.
Beautiful. And now you can see me over here, right? Here we go. Sorry about that. So we have the barrier. Jocelyn, I left you a message. We see the car and we see the can. Add arrows. Let's see if we have anybody with arrows here. There we go. This, oop, it got knocked down. We see here, good, we're showing arrows going forward, good, arrows moving. Arrows are going to show force and motion. Let's not use arrows to label because arrows in a physics diagram are going to show us motion and force, okay? I want to remind you, some of you are just showing me your forehead. I want to see your whole face. So move your camera, please, so I can see your whole face. Okay, there we go. Thank you for joining us. Okay, all right. So you have the car, the canister, the barrier. You're going to label those. Okay, make sure this is a nice drawing, but now we need to label the parts. And then we have an arrow, good, showing the motion. For this one here, good. We have arrows showing there was a force applied and motion of the canister. Okay, good. So when we are talking about diagrams, we need to make sure that we include labels and arrows to show motion and force. Okay. Number 4, describe the motion of the film canister and car throughout this activity. Let me clear your things here. Any volunteers? What happened to the car and canister through this activity? Naomi, what would you say?
The car and film canister hit the barrier, and then the film canister fell off the car.
Okay, thank you. Alexander, what would you say?
As the car went straight into the barrier, the canister fell off.
Okay, good. So when I'm looking at your number 4s, good, the film canister flew out, the car was pushed forward, the car hit and stopped, and the film canister kept moving forward. Beautiful. So we're on number 4. The film canister was consistent, with the car's acceleration. Once the car crashed into the barrier, the film canister flew away from the car. Very nice. The car hit the barrier and the canister flew. Okay, good. So go ahead and finish up number 4 now. We should all be on number 4. Annabella, I'm leaving you a comment. All right, good job, you guys. Go ahead when you're ready, go to number 5. Number 5, it's talking about inertia. Anybody remember what inertia means? What does inertia mean? Any volunteers? Don't all volunteer at once. I wouldn't want to be overwhelmed. Oof. Slow down, 5th period. Here we go. What about inertia? Anybody remember what inertia was about? Jazzy, what's inertia?
To resist a change in motion.
Okay, thank you. Kaylee, do you have anything to add?
No, I was gonna say that too.
Okay, so when we are looking at inertia, again, I want to remind you about our little elephant and our little stick guy, right? Resisting a change in motion. So number 5 says, how did inertia affect the motion of the canister when the car struck the barrier? Anybody willing to share with us? What do you think? How does inertia apply to our demonstration that we just did? So Maury, what do you think?
Because when the car hit the barrier, it like stopped and the canister flew off. Like the barrier stopped the car from going forward.
So good. So inertia of the motion, the canister, right? The canister continued to go forward. It resisted that change in motion here. Okay. So let's see what your classmates came up with for number 5. Again, if you need some ideas, now's your chance. And then we're going to take our first break. So the can doesn't have much mass. Inertia affected the canister. It flew. Good. The car struck here. The car was stopped. The car kept going. The barrier kept going forward. All right. So the canister had more. The canister continued to go forward. The car did not. Let's see if you guys said, oh, even though the barrier was blocking the car to move on, the canister kept moving because there's nothing to block it. The car stopped because it had that block to stop it, but the canister did not. So it just kept going to go this way. Okay. Questions for me? I'm looking at your formatives. Some of you have skipped a couple things. Make sure you finish. We should be done with numbers 1 through 5. We're going to take our first break. And if you don't have these supplies yet, please go get them. Get a rolled up sock if you don't have a tennis ball. Get a piece of paper if you don't have a ping pong ball. And let's take our first break here, 3 minutes. Resume recording. Now we're going to do setup B, where I'm going to use it with tape. Okay, so let me stop sharing again. Beautiful, it's already pinned here. And let me get rid of that. Okay, so okay. Can you guys see me here? We're okay. So make sure you're looking at my second video. And in fact, I'm going to turn this video off. Okay. And I can't see the chat box. Now I can. Okay. So part B, same barrier, different car. So I'm going to put this car away. I'm going to grab my other car. Very similar car, except this time the canister is taped onto the back of the car. Okay, so we're going to do the same thing. I'm going to apply a force here, and there we go. Do it again. Oop. Woo, that almost fell off. Ready? Do this again. All right. So this is what you're drawing for number 6. Okay. Go ahead now. I will turn off. All right, now I'm back on this computer. So number 6, go ahead and draw. Again, include labels and arrows to show motion and force for this one here. Okay. Jocelyn, I left you a little message, little chat box. All right. So now you are drawing on number 6. Some of us need to catch up. Good. We're showing the canister. I like how people are showing the tape on the car. Good. And we still have the arrows. We're still showing motion. Good. Now we need to actually make sure you label all these pieces. Okay. Annabella, Mia, Elijah, we're on number 6. Good. So we're labeling barrier, film canister, car, including arrows. Very good. Okay. Some of you have some great drawings, but now you need to make it a great diagram. And to make it a great diagram, you need to add labels. I see an arrow, so that's good. Now we need to label everything. Okay. Good. Let's make sure we label, especially if we're always going to label, whether we are wonderful artists or not, we need to label. Good. All right. Again, just a reminder, some of you keep creeping your video. Keep it on your face, please. It's just me looking at you. We got this. Okay. All right, number 7. If we look at number 7, we are asking now for describe the motion of the canister and the car during this demo. Do I have any volunteers that would like to share what happened during this car here? For those who are watching this video, my 5th period is one of my quietest classes. But they're going to volunteer anytime. Who would like to explain what happened to what was the motion of the canister in the car during part B? Thank you for volunteering. Ethan, what would you say?
I would say when the car stopped, the canister stopped with it.
Okay, thank you. So now what would you say?
As the the car hit the barrier, the canister didn't move because the tape was like holding it.
Okay, thank you. And then Alexander, what would you say?
I would say that when the car had hit the barrier, the canister, it didn't move because it was stopped by the tape.
Okay, those are all beautiful answers. Number 6, number 7 actually. So this time the canister actually stayed on the car as the car hit the barrier. Good. Then number 8 is asking us, how does this replicate or model a seat belt? Let me clear your hands real quick. So how does part B model a seat belt here? Jocelyn, I'm leaving you a message again. Okay, so Samori, what would you say?
It models a seatbelt because, like the one video with the crash dummies in the car, and one side had seatbelts, it like stopped it. So like the tape is like stopping the motion of the canister from going forward.
All right, thank you. So now, what would you say?
I was going to say the same thing.
Okay, so the tape is the seatbelt. When the canister or when the car, a real car, hits a barrier, you would want that seatbelt, just like that tape, to hold you in the car. We saw videos of the crash test dummy last week, and we definitely saw where that seatbelt was beneficial, right? It's going to keep the people inside the car. Very good. Okay. So we have finished numbers 1 through 8 already on your formative. If you have not, for whatever reason, continue working. What we're going to do now is we're going to go ahead and let you start the activity. But I do want to point out or show you something. You are going to end up flicking your tennis ball and ping pong ball with your fingers. Okay. If you don't have a tennis ball, then a sock will suffice. Okay. And to roll up your sock, you're just going to start from the toe part. So if I hang it upside down, let me see if I can get this to look at me only. Okay. Nope. There we go. Okay. So if we have the sock here, okay, ignore the ugliness of my sock, but it's just a sock. So I roll from the toe, right, down to the opening this way. Then I can pull over the opening of the sock to make it like a ball, okay? If yours doesn't make a ball or it's not holding, then you can go get like a rubber band. I got like a hair tie and I wrap this around to try to make it as spherical as possible. Then your piece of paper, if you don't have a ping pong ball, again, grab a piece of paper that you don't mind totally crumbling up. So just a regular old piece of paper, crumble it up as tight as possible and get it as round as possible. So smush it around to make it as round. So you need a tennis ball or a sock rolled up, and you need a ping pong ball or a piece of paper rolled up. So you need to have 2 objects here. Okay, we are going to go ahead and am here to help you if you have any questions. Okay, let me switch what I'm sharing with you guys. Okay, so again, when you have these items though, you might need to go work again on the floor, or maybe you need to go to like a counter, like another room to do the counter. I'm perfectly okay with that. We're going to leave our cameras on though, and then I'm going to be monitoring your progress on Go Formative and Go Guardian. So some of you I have to really monitor, so keep up with us. Some of you have skipped a couple questions, and I'm just going to be sending you chat messages as much as possible to help you stay on task and keep up with us. Okay, otherwise you're going to just use your thumb and finger to flick. I'm assuming you already know how to flick stuff, so if you don't, let me know. Go ahead and get started. Okay, follow the directions, and I'm here if you have questions.